Hi everyone, I am Furkan Erden, a computer science student at Bilkent University. In this video, I will be presenting my Physics 101 laboratory project, the oscillatory motion of a spring-coupled puck on an Airtable. The primary objective of this experiment was to study the periodic motion of a puck and confirm the fundamental characteristics of simple harmonic motion. Specifically, I wanted to investigate whether the period of oscillation depends on the amplitude, which is the initial displacement from the equilibrium points.
To give some background on the physics, simple harmonic motion occurs when the restoring force is directly proportional to the displacement and directed toward the equilibrium. According to the Hooke's law, the force equals minus k times x, where k is the spring constant and x is the displacement. In my setup, the puck is connected to two identical strings, making the effective spring constant k efficient equals 2 times k. Applying Newton's second law, the theoretical formula for the period is 2 pi times square root of m divided by k efficient. As you can see from the equation, the period should only depend on the mass and the spring constant, not the amplitude. This is the main theoretical prediction I set out to test. Now, let's look at the experimental setup. I used an Airtable to provide a nearly frictionless surface. A puck was attached to two springs fixed on opposite ends of the table. To gather accurate data, I used two different timing techniques: a spark timer, which marks points on the carbon paper at frequency 50 Hz, and a regular phone timer to measure the duration of 5 consecutive oscillations for comparison. Now, let's talk about the experiment. During the procedure, I placed the puck from its equilibrium position at 4 different distances: 3 cm, 6 cm, 9 cm, and 12 cm. For each trial, I recorded the motion using the spark timer and manually timed the oscillations. You can see the puck moving back and forth here, maintaining a relatively stable path thanks to the air pressure from the table. Moving on to the data and results. Here are the graphs of my measurements. Using the spark timer, the period remained very consistent at 1.55 seconds for the 3 cm and 6 cm displacements, with a slight increase to 1.65 seconds at the maximum 12 cm displacement. The average period here was approximately 1.587 seconds. With the manual phone timer, the results were slightly higher but followed a similar trend. The period ranged from 1.63 seconds to 1.69 seconds, with an overall average of 1.655 seconds. As shown in these plots, the slope is nearly zero, which indicates that the period is largely independent from the displacement.
In conclusion, both timing techniques successfully demonstrated that the period of oscillation remains approximately constant regardless of the amplitude. While there were minor deviations, likely due to slight friction on the Airtable or the springs not being perfectly linear, the experiment successfully verified the theoretical principles of simple harmonic motion. Thank you for watching.